In this video, we're solving problem 4.1.22 from section 4.1 of Essentials of Statistics, 6th edition by Mario Triola. We're asked to refer to the sample data for pre-employment drug screening shown below. It says, if one of the subjects is randomly selected, what is the probability that the test result is a false positive? And who would suffer from a false positive result, and why? So I've got all of this right here, and I've actually already typed in my answer right here, but I want to show you how we calculate this answer. So I'm going to share my paper with you, and I'll stop sharing for a moment. Okay, so this is my data. This is the table that they give us. So we had 41 positive test results that came from people who used drugs, 18 positive test results that came from people that did not use drugs, 10 negative test results from people that used drugs, and 33 negative test results from people that did not use drugs. Let's talk about this idea of a false positive. Well, this 41 represents drug users that tested positive for using drugs. So those are 41 true positives. Those are positive test results, and they reflected exactly what they were supposed to reflect. The test said this person used drugs, and they actually did use drugs. So those are true positives. Over here, in this category, we've got 10 drug users that got negative test results. So these are false because this is saying they don't use drugs and they actually do. But these are negative test results. So we would call these a false negative, 10 false negative results. Now there were 33 people in the sample that did not use drugs and got a negative test result. So that's a true negative. They're negative because they didn't use drugs, and that's what the test showed. That's great. But then we've got these folks right here. These are folks that did not use drugs, but they got a positive test result. So these are positive test results, but they're false. So these are false positives. Now we're asked to find the probability of getting a false positive. Now that we know that the false positive are these 18 folks, we just need to figure out, well, 18 out of how many? How many total people were in this sample to begin with? In order to find that, we'll need to add up the number of folks that used drugs here in this row and add up the number of people who did not use drugs in this row. So we'll calculate some totals. Whenever you see a 2x2 like this, it's probably a good idea to just calculate some totals. So these were the drug users. We had 41 drug users and 41 drug users that got a positive test result, and 10 drug users that got a negative test result. So we had a total of 51 drug users. And then we had 18 plus 33 people that did not use drugs. 18 and 33 also happens to be 51. So if we had 51 that used drugs and 51 that didn't, that means there were 102 people total. Now, just to check and make sure we're getting the right thing, I like to add up the totals in the columns as well. So if I'm trying to figure out how many positive test results I have, I'll add these positive test results to these positive test results. It looks like we've got 59 of them. And then to get the negative test results, I add these 10 to these 33, and I get 43 of those. So I had 59 positive test results and 43 negative test results. So how many tests did we have? That's just 59 plus 43, which better be 102. And it is, so we know we did this correctly. So if I want the probability of getting a false positive, well, it's 18 out of the total. So there are 18 false positives, and there were 102 people that were tested, or 102 tests that were given. So we're going to take that 18 and divide by 102. I'll use my calculator here. And I get about 0.17647, and so on. Now I'm going to go back to my screen and make sure I answer the question in the way that MyLab Statistics wants us to answer it. Okay, here we are. All right, now we wanted to round to 3 decimal places. So if we're taking this and rounding to 3 decimal places, that's going to be 0.176 approximately. And I've already typed that in, 0.176. I actually made this video and I forgot to answer the second part, so I'm making it again. Okay, so the second part of the question says, who would suffer from a false positive? Let's think about what this data actually means. These are pre-employment drug screenings. So if this false positive here, these represent people that did not use drugs and they're looking for a job. And even though they don't use drugs, they got a positive test result. And because they got a positive test result, I bet they didn't get the job. So the person that took that test and got a false positive, they're the ones that are going to suffer because they don't get the job. They would be suspected of using drugs when they don't actually use drugs. So let's look at the possibilities down here. A says the person tested would suffer because he or she would be suspected of using drugs when in reality he or she does not use drugs. That's probably it, but let's look at the other options just in case. Oops. Okay, then the next option is the employer would suffer because the person tested would be suspected of using drugs when in reality he or she does not use drugs. That's true, that statement after the because is true, but I don't know that that would mean the employer would suffer. Let's look at C. The employer would suffer because the person tested would not be suspected of using drugs when in reality he or she does use drugs. Oh, it's not that case because false positives are non-drug users that tested positive. And then the last one says the person tested would suffer because he or she would not be suspected of using drugs when in reality he or she does. Well, that's very subjective, but I think that we can say A is probably the answer we're looking for. The person tested would suffer because they would be suspected of using drugs when they don't actually use drugs, and because they're suspected of using drugs, they might not get this job, which wouldn't be cool. So let's check our answer and see if MyLab Statistics likes it, and it does. So that is how we handle that probability question.